Lesson 3.4, we're talking about multiple argument properties. So I'm going to show you where they come from. If we've got sine of 2a, you can split the 2a into a plus a, and then we can use our composite property, which says sine of a cosine b, but our b is just another a, plus cosine a sine b, and again, that b is a. And then since these are matching terms, you can add them together, so they are 2 sine a cosine a's. And that is our first double angle property. So you've got sine 2a equals 2 times sine of single a times cosine single a. Now let's do the same thing for cosine, but what's going to happen is we're going to end up getting 3 different properties for cosine. Sine has 1, cosine has 3. So I've got cosine a plus a, and we're going to look up our composite property for cosine, which says cosine a, cosine b, but our b is a, and then minus sine a, sine b, which is a. And now these are not like terms. However, we're multiplying 2 cosines, so that'll be cosine squared. And we're multiplying 2 sines, so that'll be sine squared. So that's our first property. Cosine of double A equals cosine squared of single a minus sine squared single a. Now we're going to take that and change it around. So what if we take cosine squared and plug in our Pythagorean property, and we make that 1 minus sine squared. So we're going to make that 1 minus sine squared. Again, that's Pythagorean. Now I have like terms for my sine squared. So you put those together, and you get 1 minus 2 sine squared. So that is our next property. So cosine of double A could equal 1 minus 2 sine squared of single A. Now what if I go back here and instead of changing cosine, change the sine squared instead? So we're going to leave the cosine, and I'm going to change sine squared into its Pythagorean property, which is 1 minus cosine squared. Then you're going to distribute your negative, and you get cosine squared minus 1 plus cosine squared. The cosine squareds go together, and you get 2 cosine squareds. And then there's a minus 1. So that is our third property. So cosine of double A equals 2 cosine squared of single a minus 1. And then now we're going to do tangent. So we're going to look up our tangent composite property. So we're going to go ahead and look up tangent of A plus B. And it says tangent of A plus tangent of B. Here we've got A again. Over 1 minus tangent A, tangent B, which is A. And then you can collect like terms. So we see there are 2 tangents on top. And when you're multiplying 2 tangents, you get tangent squared. And so that is going to be your next property. Tangent of double A equals 2 tangent A over 1 minus tangent squared A. Now let's try some problems with these properties. You'll see in the homework assignment that you've got lots of examples that we're not showing here because it's the same types of problems that you did in 3.3, only just using new properties. So same thought process, same steps, only different properties. But in example 1, this is kind of new. So we're going to draw an angle in quadrant 2. So go ahead and draw your x and your y. And draw an angle from the origin in quadrant 2. And then connect it to the x-axis. That puts it in standard form. And now we're going to label it with what's given to us. They tell us sine of A is 7/9. And so that means since it's sine, that 7 is opposite and 9 is hypotenuse. So you can go ahead and label your opposite with a 7 and your hypotenuse with a 9. And then to find your adjacent, you're going to do Pythagorean theorem. So you're going to have, if you subtract 49 to the other side, you're going to get 32. and then you're going to take the square root, and then go ahead and break down 32. That'd be radical 2 times radical 16, and radical 16 is 4, so 4 rad 2. And then when you look at your triangle, 7's going up, so it's positive. The diagonal is always positive, and 4 is going left, so it gets a negative on it. And our A is always there, the angle between the diagonal line and the x-axis. So now they want us to use this picture to find sine of 2a, cosine 2a, and tangent 2a. So let's find sine 2a first. If we knew a, we could plug it in, double it, and take the sine of it, but we don't know what a is. So we're going to have to use our property from the double angles table on the front, which says 2 times sine of a, cosine of a. And looking at our picture, we can find sine of a. Sine of a would be 7/9, which was given to you. Or, if not just given to you, you can do opposite over hypotenuse. Cosine of a is adjacent over hypotenuse, so you're going to have negative 4 radical 2 over 9. Then you want to go through and multiply these. There's an invisible 1 on the bottom. So on top you have 2 times 7 times 4, and that makes 56. And then you have radical 2. And on the bottom you have 1 times 9 times 9, which is 81. And that would be your sine of 2a. Now we're going to find cosine 2a. And you've got 3 properties to choose from. So you can decide what you want to do, which one you want to use. I'm just going to use the first one. So we have cosine squared minus sine squared. And so when we look at the picture, we've got cosine, which we also could just take from the one we did, is negative 4 rad 2 over 9, adjacent over hypotenuse in the picture. We have sine, which we already know is 7/9, or you can go ahead and look up at your triangle and do opposite over hypotenuse. And then you put squares on them because it's cosine squared and sine squared. And when you square something, you got to square everything in the fraction. So you're going to have negative 4 squared is 16. Radical 2 squared is 2. 9 squared is 81. Over here, 7 squared is 49. 9 squared is 81. 16 times 2 is 32. And you're subtracting 49. So when you combine like terms, you get negative 17 over the common denominator, 81. So again, I just did 32 minus 49 to get 17, and then 81 on the bottom. Now we're going to find the tangent. So now to find the tangent, you can use one of the properties, or the property that you have on the front. However, it's easier just to do sine divided by cosine. So to find tangent 2a, you can take sine 2a divided by cosine 2a. And we know sine 2a from the problem we just did is negative 56 radical 2 over 81. We know cosine from the problem we just did is negative 17 over 81. And now we have a fraction divided by a fraction, and you would multiply by the reciprocal. So I'm leaving the top fraction alone, and I'm going to flip the bottom fraction upside down. And the 81s cancel, and you get, and the negatives cancel. So it's 56 radical 2 over 17, and that is the tangent.